Okay, last time we already go through this thing, right? All of this thing we already done. Okay. Okay, let's see. um, Binary addition. That means you want to add it to number in the binary. 0 add to 0 will be 0. 0 adding to 1 will be 1. 1 adding 0 will be 1. Only thing is 1 adding to 1, then you get 0. However, they have to be carry 1. Okay? So now we're adding 1 to 1 1. 1 1 to 1 1, see what you get. 1 1 1 1. Add it. 1 adding to 1.
0 and 1 carry.
Carry 1. Now, what that means, carry 1? Carry 1 means adding 1 to the next column.
And then 1 plus 1 plus 1 equals 1 carry the 1.
To next column. Okay, so 1 added to 1 to be 0, carrying 1. Mean now you're adding 1 to the next. So 1 adding to 1, you get a 0. 0 adding to 1, 1, still carry. So that is the answer. Okay, now if you see the decimal, 1 1, what is the decimal?
2.
3.
3. 1 1 3. 3 adding to 3, you get
6.
6. 1 1 0 means number 6. That is easy to adding to number, except when you get a 1 adding to 1, you get a 0. However, you must be carry 1. And we already said carry 1 means adding 1 to the next column. Okay, now we're adding 100, 1 0 0, adding to 0 1 0. 0 to 0, you get the 0. 0 adding to 1, you get a 1. 1 adding to 0, you get a 1. Okay? So if you want to know the decimal, then that will be number 4. That will be number 2. 1 1 0 will be number 6. Okay, now you try to do number C for me to see what answer you get. 1 1 1 adding to 1 1. 1 1 1 adding to 1 1 means 0 1 1.
I believe 1010.
I don't know. Let's see. What
I
do you
agree.
get?
I agree with that.
Okay, you can say 1 adding to 1 will be 0. Carry 1. Carry 1 means you adding 1 here. 1 adding to 1, 0. 0 adding to 1, 1. Still carry. Adding 1 here. 1 adding to 1, you get 0. 0 to 0, you get 0, but still carry 1. So what's the number here? I think that's 7, right?
Answer A.
And this number will be 3.
3.
So decimal for 1010 will be number 10.
But 10 is A.
Right, that high decimal. We're talking about decimal number, not the high number. Okay, the last one will be D.
1010. The answer?
Let's see, D, that means you get 6 plus 1, plus 4, you get 10. The answer will be 1010. Okay, any question? How to adding binary number? Okay, now subtraction. 0 minus 0, you get 0. 0 minus 1, you get a 1. However, you borrow 1. 1 minus 0, you get 1. 1 minus 1, you get 0. Okay, borrow 1 means what?
If it is a 1, make it 0.
Next column.
Borrow 1 means subtract 1. From next column.
If the next column is 0, then what?
I don't know. Now, why we say 1, 1 minus 0, 1. 1, 1 minus 1, you get 0. 1 minus 0, you get 1. Okay? And the next one, 1, 1 minus, okay, 0, 1. 1 minus 1, you get 0. 1 minus 0, you get 1. Okay? And now you can get 1, 1, 0, 1. Minus 0, 1, 0, 0. So 1 minus 0, you get 1. 0, 0, you get 0. 1 minus 1, you get 0. 1 minus 0, you get 1. Okay? and the last one 1001. Minus 0, 1, 1, 1. 1, 1, 1 minus 1, you get 0. 0 minus 1, you get 1, right?
0
Borrow
minus
1.
1.
Okay. Borrow 1 means you subtract 1 from ninth column. That means you will be subtract 1 here. 0 minus 1. You get a 1, still borrow 1. Then 1 minus 1, you get a 0. Borrow 1 means you still minus 1 here. 1 minus 1, you get a 0. 0 minus 0, you get a 0. So the answer will be 0, 0, 1, 0.
Mr. Pham, can you repeat one more time? Can you explain again?
Okay. 1 minus 1, you get 0.
Yeah, that's correct.
0 minus 1, you get a 1. But you get a borrow 1.
Mm-hmm.
Borrow 1 means you subtract 1 from ninth column. So 0 will be minus 1.
But the 0 here is a binary 0, am I right?
That is everything is binary right now.
So can we write binary 0 as negative 1 also when we subtract?
I say 0 minus 1.
Yeah, that is minus 1.
Okay, then what you get? You get a 1. Right?
Yes.
And still borrow 1. So that's why I say 0 minus 1. You get a 1. That 1 will be minus 1. That's why you get 0. But you still get a minus borrow 1. So that's why you have to subtract 1 from next column.
Mm-hmm.
So 1 minus 1, you get 0. 0
Yeah, I got it.
minus 0, you get 0.
Yeah, I got it. Thank you so much. I appreciate.
Yeah, you're welcome. Basically, this one you need it in order you can doing something else. But for this program, we don't want to go too much detail on this thing. Okay? The thing is, the technician, we're not doing anything with this thing.
Mr. Pham, it seems almost just as easy to just convert the numbers to decimal and do the math and then convert the answer back to binary. At least when they're small numbers like that.
Yeah, whichever way you want. But you have to remember for me, when
Yes.
you subtract 1, it's to 1. To 0 to 1, you get a 1, you borrow 1. And you have to know how to using that borrow. That's good to me. No matter which way you want to do, only thing you can get the right answer. Is it anyone could ask something? I couldn't hear. Look like you get the some feedback, and that's why the voice is not clear. Okay, we go to complement a binary number. The first complement and the second complement of a binary number are important because they permit the representation of a negative number. Okay, basically I am telling you, the computer, they have to deal with either positive number or the negative number. For example, plus number 5 or minus number 5. That means they have to know how to take care for the negative number also. So in order to do it, they have to need either the first complement or the second complement. That means in the computer, they get a circuitry to build to take care either one. They can using second complement or the first complement. However, computer now they're using second complement, okay? Make sure you understand the reason they're using the second complement. They need to deal with the negative number, okay? So the method of two complement arithmetic is commonly used in a computer to handle negative number. After completing this section, you should be able to converting a binary number to first complement or to second complement. So now first complement first. You get a first complement, then they say the first complement of binary number is found by changing on 1 to 0 and on 0 to 1. That's an easy one. Okay? So you get a binary number 1, 0, 1, 1, 0, 0, 1, 0. Okay? This is the number here. And if you want the first complement, change 1 to 0 or 0 to 1. That's what you get, first complement. And in order to find a second complement, first step is you find the first complement. Then you adding 1, you get a second. So now, on this one, what the second supposed to be? Who get the second? Okay, you get number 1, 1, 0, 1, 1, 0, 0, 1, 0. That's the binary. And now the first complement, change 1 to 0, 0 to 1. That's first complement. If you want second complement, adding 1. So they say you adding 1. You get the second. So 1 adding to 1, you get 0. 0, 1, 1, 0, 0, 1, 0. That's easy to get a second complement. If you couldn't follow it or confusing anything, just bring it up. We try, that's a very basic. We want to make sure you know how to do it. So to get the first complement, converting binary from 0 to 1 or 1 to 0. In order to get the second complement, first thing you need to get the first complement, then you adding 1. That given you second. Okay, now go ahead and finish that section Jacob. That means they want to number A, first complement, easy, right? You can get 1, 1, 1, 0, 0, 1, 0, 1. Okay? Just can 0 to 1 or 1 to 0. Okay, and now I go into number A of a second complement. I do only 2, okay? You get a second complement. First thing you get first complement. Number A. First complement will be 1, 1, 1, 0, 1, 0, 0, 1. Okay? And now you're adding 1. That's what you get second. So 1 adding to 1 to be 0. And that will be 0, 0, 1, 0, 1, 1, 1.
Hey, Mr. Pham, shouldn't that first one should have been 0 carry 1?
Which one? 1 adding to 1 equal, is it 0 carry 1?
Yeah. Because
Okay.
the part where you're doing the second complement.
Okay. 1 adding 0, you get 1. 1 adding to,
1 and 1 is 0 carry 1.
okay. 1 adding to 1 will be 0 carry 1. Thank you.
Mhm.
Carry 1 means adding 1 to the next column.
Right,
0 adding to 1, you get a 1.
right.
Okay, 0, 1, 0, 1, 1, 1. Thank you, Mr. Smith.
Okay, I give you an A for that, Mr. Pham. All right.
That's easy, right?
Too easy.
Adding to number, subtract to number, first complement and a second complement. Okay, side number, I skip that for now. The thing is basically that really don't need to apply for this technician, okay, at this time. We will go over when we get a time, okay? There's more detail inside the computer. Okay, let's see. What else? Okay, this is really, you guys will be needed. Binary to the hexadecimal conversion. The thing is this one will be applied a lot of time, okay? Converting a binary number to hexadecimal straightforward procedure. Simply break the binary number into 4-bit group, okay, at the right mode bit, and replace each 4-bit group with the equivalent hexadecimal symbol. Okay, that means from number A, you count 1, 2, 3, 4. Okay, 1, 2, 3, 4. One group, 1, 2, 3, 4. Second group. Okay, now converting each one. 1, 1. What number?
That's, oh, you mean, you going from right to left?
From the right to the left.
Okay, 0, 1, 1, 1 is
Robert.
7. 0, 1, 1, 1 is 7.
Now I go to the most significant bit 1, 1.
It's 3, but we go from right to left.
You
Yeah.
got 3 ones there,
Right
Mr.
to left means you divide it.
I know, Mr. Pham, but
Oh, I got it.
Okay, what's the next number?
It's 2.
Next number.
It's very close. It's 5.
Mr. Pham, can I stop you there for a minute? I think when you divided it, it's not into 4s.
I agree with you. I agree with you. Mr. Pham, you didn't divide them up right.
You got
Okay, let's see.
2 digit and then
1,
6
2, 3, 4. 1, 2, 3, 4, 5. Yeah. Sorry.
divided wrong.
Huh.
It's since his numbers are very close, it's very hard to.
Yeah. Okay, you go ahead and do it. Tell me what number you get. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I believe that's okay.
EA57.
So the first 1, 1, 0, 0, you get a C.
Right.
1, 0, 1, 0, you get a
A.
A. 0, 1, 0, the 5, 0.
And then 7.
If you, whoever don't get it, let me know.
Can you explain it again, Mr. Pham?
From the right to the left, divide X group 4 bit and try to find the symbol for the height for X group. Okay, so the first thing you get a 1, 1, 0, 0, you get a table, you know that will be a C. And the next number 1, 0, 1, 0, you're looking into the table, you get an A. And so on. Okay. If you couldn't remember the height, then you need the table for a while.
I'm not sure, but I got answer 1F969.
You get the number A, right? 1F.
1F969.
How come you get a 1? You get a 1, 1, 0, 0. You're looking into the table. You convert into the height. 1, 1, 0, 0. What number?
C.
1100 is C, is in Charles.
Let's see. I want to see. We get a table in here somewhere.
1010 is A.
Okay, we don't have a that table right now. Okay, but
The answer is CA57.
exactly.
Yes.
Good job, Kumi. You get an A.
Thank you.
CA57.
Right. That's right.
If someone don't know, I can give it to you. 1, 0, 1, 0, A 1 0 B data height 1 1 0 C 1 1 1 0 E F
You forgot the D, Mr. Pham.
A B C D.
D, E, F. After the C, you got to put D.
Yeah. 1 1 0 1.
Correct. And then E, 3 ones and a 0, and F, all ones.
Only number 0 to 9, same thing.
Right.
Nothing yet. Okay, do for me number B. Tell me the answer.
9. That's 9. That's 6. 1. F. 3. 3F. 1.
Okay. What
3F 169.
You say 3F 169.
Correct.
Perfect. You can see they given you answer right here.
Yeah.
But I want you to get that out to make sure you get that right answer.
All you're really doing is dividing all those numbers up into 4 bits, and then you match them up with the table.
Right. Very simple. Try to do a related problem. Tell me the answer. And make sure you understand. Must be reading hand out over and over. When you go into the college, they assign, what chapter in the textbook, and they keep telling you, reading over and over. This time I change the way teaching like close to the college. However, will be more in dealing with the lab. Up there, they cannot do the lab like we do it. Okay, who get answer for related problem?
4F7 9C. 4F7 9C is in Charles.
For F7 9,
C is in Charles.
right?
Right.
Okay, see anyone agree with that? So make sure if you behind on the lecture today, you can go to the web, okay? To reading, you watch again for recording. Okay, the related problem answer will be for F79C. Everyone agree that?
How did you get this one?
Okay, from right to left.
Okay.
1, 2, 3, 4. 1, 2, 3, 4. Who asking me?
Who, me?
Go me. How come?
I don't
1, 2, 3, 4. 1, 2, 3, 4. Then convert it. 1, 0, 0 will be 4. Okay? For F79C. Correct.
Yes. Yes. Thank you.
She's a technician.
Yeah, right.
Yeah, she doing good. But
Yeah.
sometimes make me surprised.
Ooh.
Okay, BCD. BCD stand for binary code decimal. That means they are binary, but they working like decimal. So that in the BCD, you only get a number 0 to 9. You cannot get more than 9. The thing is, decimal will be the same thing, 0 to 9. Okay? But the BCD, they are using the binary. So one thing you must be understand, in the decimal, okay, you get the number 0. However, BCD require 4 bits for each digit. So that's why you get 40. And now you go to number 1 in the decimal. And the BCD is still 1, but you have to get 0, 0, 0, 1. Again, they must be 4 bits. Okay? Example, they want to convert 35 to BCD. Then the first thing, number 35, okay? And you can see number 3 will be 0, 0, 1, 1. You see that? They must be 4 bits. Then number 5, 0, 1, 0, 1. That's very easy. Okay? And they give you number 98. So you generate number 9 will be 1, 0, 0, 1. And number 8, 1, 0, 0, 0. Okay, the next will be the C and D, they already get the answer. I don't care. Do a related problem for me. Doing that one. 9673 to BCD. So number 9 will be 1, 0,
1.
1. Number 6, 0, 1, 1, 0. 7,
0,
0,
1, 1,
1,
1.
3.
0, 0, 1, 1.
They must be 4 bits. That's only thing you must memorize. And then they say converting BCD to decimal. Same thing. From the right to the left, divide for width for one group and change equal. 1 0 0, that means you get number 8. 0 1 1 0, you get number 6. Easy. And the test solution you already get for ABC. I want to get it done for related problem for me. Try to see. Convert BCD code to the decimal. Tell me what the answer you get.
So that's going to be 6. Yeah, right.
Who get the answer?
Trying to keep my eyes straight, Mr. Pham. There's so many ones and zeros. You
Exactly.
gotta. If you go from right to left, you got 6, then you have 7, then you have 2,
2,
2,
8.
8. Yeah, that's right. But you have to keep your eyes straight.
And
You should have powerful eyes like Mr. Pham.
2 2
Yeah.
7.
6.
Only thing you know how to do it, that'd be fine. You know, too much 0 1, it's hard to, you know, get the dry away. So the answer will be 82276.
Correct.
Okay, see what else? Okay, BCD addition. You add the two numbers 0 0 1 1 adding to 0 1 0 0. Okay, so you can see they can add in here 1 adding 0 1, 1 adding to 0 1, 0 adding 1 1, 0 0. Okay, answer will be 0 1 1 1. The next one.
Hey, Mr. Pham, a question on that. Mr. Pham?
Yeah.
So it says add the BCD numbers. So basically, we would add them up like we did when you first talked about the addition, correct?
Right.
And then after you add them up like that, then you can break them into 4 bits for the BCD number.
Right. Don't cut adding normal. However, you can hit into the problem is when you're adding the number and the binary that's higher than 9. Then you have to add in 6 more.
Hey, can you give us an example of that?
Yeah, we will try to see. Okay, A, now you already get it. And now I try to the B. Okay, 0, 0, 1, 0. Add it, you get 0, 0, 1, 1. And now you adding to 0, 0, 0, 1. 0, 1, 0, 1. 1 adding 1, 0. Carry 1, right?
Right.
1 adding to 1 is 0. Carry 1. 0 adding 0, 0. Carry 1 here, you get a 0 adding to 1, you get a 1. 1 adding to 1, 0 carry 1. 0 adding to 1, you get 1. 1 adding to 1, you get 1. Okay?
Right.
And now 0 adding to 1, you get a 1. 1 adding to 0, 1, 0, 0. So this is number 3, right? This is number 8, right?
Right.
Okay, that is number B. And now I adding number C. 1, 0, 0, 0. 0, 1, 1, 0. Adding to 0, 0, 0, 1. 0, 0, 1. 0 adding to 1 is 1. 1 adding to 1, you get 0, carry 1. 1 adding to 1, you get 0. 0 adding to 0, you get a 0, still carry 1. 0 adding to 1, you get 1. 1 adding to 0, you get 1. 0, 1 here, 0 here, 0 here, 1 here. That's number 99. Let's see, I want to adding the page is what here? Okay, so adding to here. Okay, so now what I try to do is BCD here. So we don't want that. Delete, clear pair, delete. Okay, I can see. Adding pair here.
Oh, yeah, this right, the one on the bottom, Mr. Fair. Oh, you just went past it.
Yeah.
Yeah, right there. This is the one where you need to add 6.
Okay, so I want to relate problem here. Okay, I want to see. Okay, I know. I know what's going on here. Copy. Okay. Huh. Paste about. Okay. Okay, I know what's going on here. Okay, just a minute, okay? I find a way. I don't want better message. I want to delete it. Okay, I'm going back to this guy. Okay, let's see. That one. Okay, so we can copy that guy. Okay, then we go into that guy here. Paste them out. Okay, so now they want to add in these two numbers. Okay, you get a 1. How come too big? Oh, the thing is we make it big. Okay, 1, 0, 0, 1, 0, 0, 0. Okay, 0, 0, 0, 0. Then 0, 1, 0, 0. Then 0, 0, 1, 1. Too much. Adding to 0, 0, 0, 0. And adding to number 9, 1, 0, 0, 1. And 0, 0, 1, 0, 0, 0, 1, 0. Okay? And 0, 1, 0, 1. So basically for this adding, nothing we can talking about, just normal. 1, 1, 0, you get 1, carry 1. 1 adding to 1, you get 0, 0 adding to 0, 0 carry 1. 1 adding to 0, you get 1, 1, 0, you get Okay, let's see. 1, 1, 0, you get 0. Carry 1. 1 adding to 1, you get 0. 0, 0, you get 0, carry 1. 1 adding 0 to get 1. 1 adding to 1, you get 0, carry 1. 1 in here, 0 come here. Okay, that is normal, nothing special. Okay, I want to make sure we get that one. That's what we want to do. Adding 1, 0, 0, 1 to 0, 1, 1. Okay, now. Where we are now. Okay, here. They want to adding 1, 2. Okay. 1 adding to 1. Carry 1.
Mr. Fan, where'd you get that? Where'd you get 0101 at? Are you doing 9 and 4 or 9 and 5?
4. Okay.
If you're doing 9 and 4, yeah, there's got to be a 0.
Okay, thank you.
Mhm.
I'm messing up with 0 and 1. Ha,
It's okay. We're all human, Mr. Fan. Okay,
I get older, man.
me too.
Okay. 1 adding to 0, get 1. 0 at 0, you get 0. 0 at 1, you get 1. 1 adding 0, you get 1. Okay? You see that?
Yeah, I see.
What that number?
That's 12, 13.
Okay, this number in the decimal.
Oh, I see. And the BCD can only go up to 9.
Exactly. You see that? When you get the number, you're adding it to higher than 9. What you need to do, you need to add the number 6. 0, 1, 1, 0. They say add number 6. Okay? That is the rules we have to do. Adding again. 1, 0, 1, 1, 1, carry 1. 1 and 1, 0. Adding 0, 0. And carry 1 still here. Okay? So the number here will be number 9. You adding to number 4. Okay? You're supposed to get number 13. So now you can see this is number 1. This is 0, 0, 1, 1. So that's why you get 13. So you understand that? That means BCD cannot be higher than number 9. So when you're adding it, you get more than 9, then you have to adding number 6 in order to get the answer.
Hi, Mr. Pham.
Yeah,
This number 13, the answer you got is not a decimal number, it's a BCD number. Am I right? This is correct?
correct.
Yeah, thank you so much. I appreciate. So if it is written 13, then they have to specify BCD. If otherwise, we will understand it as 13, if not specified.
What do you mean 55? Where we get 50?
Yeah. If number 13, just like it is given, then I may consider it a decimal number 13. But if this 13 means BCD, then they have to write something on the front or the back. This 13 is BCD, not a decimal number.
Okay. If I say I want number 13 in BCD, right? 13 in BCD. So basically 0, 0, 1, 1, right? No, 0, 0, 0, 1. And 3 could be 0, 1. So basically that will be equivalent to number 13 in the decimal.
Oh, yes, thank you. I got it.
Okay. Gray code. Yeah, quickly we can get through that thing. Gray code is unweighted and is not arithmetic code. Okay, so basically you can read it. Okay, we don't have enough time. So if they given you 4-bit gray code, so you get a decimal 0, you get a binary number. Okay, and then you can get the gray code equivalent. That's the table. Okay, go up to 15. Now, I want to talk about if you get a binary, how can we get a gray code? So if you get a binary 1, 0, 1, 1, 1, 0, you want to convert into the gray code. Okay, first thing, this one. Okay, this one here, you bring down here. That's the first step. Then now you adding 1, adding to 0, you get a 1. Then you adding 0 to 1, you get a 1. You adding 1 to 1, you get 0, no carry, okay? You get a 0. 1 adding to 0, you get a 1. So you try to see you can get 1, 0, 1, 1, 0, 1 to the gray code. Okay, 1, 0, 1, 1, 0, 1. That's the binary. Now the gray code. Put a 1 down here first. Okay, then 1 adding to 0, 1. 0 adding 1, 1. 1 adding 1, 0, no carry. 1 adding 0, 1. 0 adding 1, 1. That's very easy, right? And also I already given you answer for number A and number B. Right here. You try to see you can get the right answer on number B.
Isn't A and B the same question?
Oh, okay, so typo. That's okay. No big deal. Go to the next quarter here. Read that telling me how do we convert it to the gray code to the binary. And try to do related problem for me. Number A and number B. If you can follow it, I can tell you. First thing, this number 1 here, just bring down here. 1. Okay, then you take this one adding to this one. 1 adding to 1, you get 0. Then take this 0 adding to 0 here. 0 adding 0, you get 0. And 0 adding to 1 here, you get a 1. 1 adding to 1, you get the 0. No carry. Okay? And now you're doing for number A. Tell me what number you get. Who get the answer, let me know. Number A.
One, 0, 0, 1, 0, 1, 0.
Okay, 1.
1,
Next,
1,
1.
0, 0, 1, 0, 1, 0.
Is that answer, right?
Yes.
You agree with that?
Yes.
Okay, give me the next one, B.
1, 1, 1,
1, 1, 1.
0, 1, 0.
On that first one, when you get finished, I missed something on that one. Maybe I crossed something up wrong.
Yeah, the thing is digital, that's very easy. Much more easier than electronic. Okay, number B, 111010. Is it correct?
Yes.
Okay.
Hey, Mr. Pham, can you do A again? I just wanted to see something.
Okay, you want A.
Yeah, just talk us through it again, because I think I missed the, I must have
Okay,
missed,
one, put it one here,
Yeah.
right?
right.
1 adding 1,
0,
0 adding 0,
0,
0 adding 0,
0,
0,
0 adding 1,
1,
1,
1 adding 0,
1,
1,
1 adding 1,
0,
0,
0 adding 0.
0.
0. Yeah.
Now, Mr. Tai, you do know that you're adding, you're finding the gray number to the answer of the original question. You're not doing it to the original binary.
You get binary, you can get the gray code, right?
Right. No, I'm just saying you're doing A. You just did the gray number to the answer and not to the question. The question was 1010111.
Okay, so what the answer?
Then the answer will give you 11001010, which is the answer.
Right,
And then you just did the gray number to the answer.
right.
Okay, that's fine. As long it's just that Mr. Smith was asking how you got that answer originally. Thank you.
Yeah, thanks a lot, because I missed a digit. That's what I think happened. And if you miss a digit, then the whole thing throws off.
Exactly. Okay, ASCII code we don't want to talking about. Okay, basically on your keyboard, they coded by the American Standard Code for information interchange. That means telling you what the number 1 equal binary or what number 2 or letter A, lowercase, uppercase equal to what binary number. The thing is what I'm saying is computer don't know anything about the alphabet. They only know the binary. So that's why in your keyboard, they get a circuitry to converting. When you type number 1, they have to converting to the binary so the computer can understand. If you want to see the table, go to the Google, typing ASCII, they given you the table. Okay, we don't care that. Okay, and now we really care here. Boolean, algebra. Number 1, A adding to 0 equal A. A adding to 1 equal 1. Remember, 1 adding A, adding B, adding C equal 1. Anything adding to 1 will be equal to 1. Okay, when you're doing a digital lab, 1, that means you connect to what? If they say connect A to 1, where you connect it?
The 5 volt or the high
5 volt.
5 volt. You understand you get only 0 and 1.
Mhm.
1 means 5 volt. 0 means ground.
Wow.
So anything connect to 1, that means you connect to 5 volt. So 1 adding to A or B or C or D, they still be 1. A times 0. 0. Anytime 0 will be 0 anyway. A and 1 equal A. The thing is depend on A. If A 0, you get 0. If A 1, you get 1. We understand in a binary, you get only 2 numbers. They not 1, they be 0. Or they not 0, they be 1. Okay? A or A. You cannot get to A. We don't have number 2. So they must be equal A. A0 means you get 0. A1, you get a 1. Okay? So A times A. This is wrong here. We don't need that, right?
Yep.
That's just duplicate. A times A. You get A. You cannot get A square. A0, you get 0. A1, you get 1. A and not A. You get 0. You know why? The thing is, if A equal 1, then not A must be equal 0. So 0 times 1, you get 0.
Oh, the second one, is that not A?
The next one, number 9.
No, number 8. Is that like a quote or not A or something?
Okay, that number 8, I draw number 8 here. Okay, the thing in the PowerPoint take a long time in order to get A and not A. Then I have to using A.
Oh, okay.
Same thing, not.
Oh, I see. You got to use the quotation marks.
Quotation. Right.
Okay, all right, got it.
Cannot get this one.
All right.
Take a long time. Okay. Now, next one. A, not. They go back to A. For example, if A is 0, right? And not 0 will be
1,
1.
One.
Not 1,
0.
so they will be go back to original. Now, A or AB.
Hey, Mr. Pham, I know you on something. When you get that like that, when you get the A with the double knot, is that like, because I see 0, 1, 0, so is that like you going from a low to a high to a low?
That means they go back to original.
Yeah, but I mean, from a circuit standpoint, is that like going low to high to low?
Right. Low, high, then low again.
That's a pulse then.
Yeah.
Okay.
Okay, now A or AB. I can prove it for you. A or AB, you can put A and you open. You get a 1, you add into B. 1 add into B, what you get?
1.
1 times A, they will be, that's why they will be equal A. And A or B and A or C, they will be A or B, C. Okay? If you want it, you have to do it something. We don't care that thing. I only care in here. This is the one. When you get a not XY, that's what they call a product. The thing is X times Y, that means product. And then you want to break out that bar over here. What you need to do? X will be turned out to be not X. X and Y have to be converting to the R. Okay? And Y going to not Y. So this is the sum. So you converting from product into a sum. And now you get a sum right here. X plus Y with the bar over. You take the bar out. X will be not X. Or plus will be N. And Y will be Y not. Okay, not Y. So now you get sum and you converting to this is the product. Okay, so let's see. Apply the Morgan law. That's what we call the Morgan law to the following expression. Okay, A, not A or B or C and D. Let's see, I try to say I want to get the adding pay. Okay, and I want to copy that guy. Copy, and now I go paste in here. Okay, so we want to get number A. Okay, A or B or C and with D, and you get the bar over. That means not everything. So now you convert it. You need to remove the bar here. First thing I can see, A or B or C. Or B or C. This is the bar here. And now I need to break this guy here. They must be or and not D. Okay. And now I need to break a bar over this guy here. A turned out to be not A. Blood have to be M, not B. Blood have to be N, not C, or not D. Any question on this problem?
What does the dot mean?
Dot mean N.
Thanks.
Okay, later on you can see. If you see a dot, that equivalent to N, or get, or. Dot mean N, time. Okay, add mean blood. Dot mean time, A time B, or whatever. Now you're doing for me number B.
Hey, Mr. Pham, I hate to be a pain. Can you go back to that grade code? I wanted to, there was a note that you wrote down that I wanted to copy in my notes when you get a chance.
Ray code.
Yeah, there was a note that you wrote down that I wanted to copy.
Maybe I already erased it.
Okay, never mind then.
Just check the
Okay,
report.
now do number B for me.
Yeah, I'll check the recording.
Yeah, when you go into a web, you can see.
Yeah.
So number B, A naught plus B naught plus C naught.
Yeah, we'll see. Number B. Okay, so we A, B, C. Okay, R, D, E, F. And you get a bar over. I remove the bar. Okay. Okay. You can get A, B, C, not here. Blood now will be time. D, E, F with the bar. Break it again. Not A
Not A,
or not B
or
or
not,
not C and not D or not E or not F.
Mr. Pham, don't they need to be in bracket when you have the n? So bracket A, B, C times bracket D, E, F. Right?
Okay, now you're talking about A or B.
Number B.
Okay, number B. 14. What you need to do is you have to deal with either in or outside the product.
Right.
Do this first. In order to do that, ABC still have not over.
Mhm.
DEF not over.
Right.
Plus,
Follow that part. But then on the next part, when you break ABC, shouldn't that be in a bracket? A not A plus not B not C or bracket times not D.
mute.
okay, I see what you say. Okay. You saying we better put her here, right? Okay, not A or not B or not C. Then you can end with not D or not E or not F. Correct. Okay, the last one, C. Who can get the answer? Let me know. Number C. Okay, A, B. Okay, not here. Or not C. D. Or E, F. Everything at the bar over here. Okay, first thing you need to take care of this guy. Take care of this guy. So you can get A not B not. That will be N. Not C D. Not. That will be N. Okay? You get that?
Shouldn't A and B both be not?
So now A and B not. So now you can say A not, right? Or
B
B
or bracket.
not, right?
Yeah. Which is just B
And C
times.
not or D not. And E not R F not.
And they should be all in the bracket, right?
To multiply it. Okay, that means this guy multiply to this guy.
Yeah. Okay. Thank you.
Same thing here. Okay. Now you get not A or B, right? The thing is B not means to go back to original. And will be time to C or not D. Then they will be N to
Not E, not F.
see the time is too fast. Almost. Okay, so I try to quickly go to this thing. Let's see, this one here. Okay. This is one you need to deal with.
All the gates.
Yeah, we're talking about the gate. Logic gate. The first one, the gate will be the AND gate. When you see the symbol here, then you must be know this is the AND gate. Okay, and the part number, and you can see this is the part number 7408. Now, for the AND gate, basically, they must get 2 or more input. However, they get only 1 output. Okay? And the equation for the output will be y equal a times b. However, we say a and b. Okay? So everything I see, we can get the truth table. That's what we call a truth table right here. Okay? First thing, a truth table, they get only 2 input. So you get a 4 combination. 0, 0, 1, 1, and 0, 1, 0, 1. And now the output will be equal 0, 0, 0, and 1. If you want to know the output, you're looking into the input. Okay? If you get the input is 0 here, 0 here, then you get 0. Or if you get a 1 here, 1 here, you get a 1 here. How do I know? That's the thing that truth table telling me. However, this is important thing here. They say output equal 1 if all input must be 1. Okay? I given you the example here. If I get this and get here, A, B, C, And the output Y will be equal A and B and C. If I say A equals 0, what output?
0.
0.
0. Okay? For the AND gate, one input, 0 output must be 0, no matter what. The thing is, if you get 0 here, 0 and B will be 0. Or 0 times B will be 0, 0 times C will be 0. We don't care about B. You don't care about C. So that's why when you apply 0 at A, you suppose to get 0 out. If it's not something wrong, that means instead 0 here, you not get 0. You can get anything else, I don't care. Then you troubleshoot it. What you need to do, you go back to A using the meter to measure at A. If you get any voltage less than 0.8 volt means 0. That's correct. Then what happened? What you have to do?
You have to go backwards.
Now, what I'm saying here, you get the AND gate, 3 input ABC. You want to apply 0 to A, and you supposed to be get 0, right? But you not get 0.
Oh, okay.
You can get 1 volt, 3 volt, or whatever. That's not 0. Then in order to fix the problem, you say, okay, I go back to A using meter to measure A. If I get 0 at A, what can we do?
Change the part.
Exactly. You can say, this gate is not working. Why? The thing is you get an input A 0, output must be 0. I don't want you to take the measure and B at B. Right? The thing is one input 0, output must be 0. So B can be 0 or B can be 1, that doesn't matter. Okay? So that's why normally later on they can say I mean what?
Don't care.
Don't care. So now you get 0 in binary, 1 in binary. And now you learn one more. I will be don't care. What that mean for don't care?
It can be 0 or 1.
They can be 0 or 1, doesn't matter to me. That's why I say don't care. So when you say don't care, you don't have to take any measurement. Okay? That is how we troubleshoot it. Now, this is the IC. Okay, for the AND gate. This is the IC for 7408. Inside this IC, you get how many gates? 1, 2, 3, 4. And also they identify for you pin 1, pin 2 input of the first gate, pin 3 output, 4 and 5 input of the second one, and so on. So any IC, they must get the power and ground. Without the power and ground, the IC not working. For this IC, pin 14 must be connected to 5 volt, and pin 7 must be connected to the ground. And I given to you this thing here, you can see. See that IC right here. See that?
Right.
The IC here, you see the dot right here. That means pin number 1. 1, 2, 3, 4, 7. Okay. Go to clockwise, right?
Right.
Okay. 14 will be power. Okay. This same thing for every IC, different part number. If you understand the first one, the rest will be more easier. Okay, I repeat it. Okay, and gate, that means the gate get a 2 or more input. However, you get only 1 output. That's for AND gate. And the equation will be A and B. So you get the truth table for telling you get a input AB, you're able to know what output. However, only one thing you need to make sure you understand. A output will be 0 right away if any input equals 0. However, if you get a 1 here, you get a 1 here, then output will be
1.
1, right?
All inputs must be 1 to get a 1 on the output.
That right now we're talking about AND gate.
Right.
Okay. Only thing is you get an input on 1, output will be 1. Otherwise, output must be 0. Okay. OR gate. And now you can see that the symbol is a little different right here. That will be OR. OR gate the same thing. They can get 2 input or more. However, only 1. And the equation will be A plus B. But we have to say A or B. And also the truth table will be telling you 0, 0, you get 0. 0, and all 1, you get 1. Okay. They're telling you one thing. Okay. If the OR gate, they get a 1 input to 1, then output must be 1. Okay. The thing is 1, you OR with anything, you still get 1. Okay. That's why in here, they say 2 or more input, 1 output. Output is 0 if all the inputs are 0. And the part number here, 7435. And this will be inside that IC 7432. You get 1, 2, 3, 4 for gate or gate. And they tell you what pin is 1 input or what pin will be output. The same for the OR gate. Okay. Inverter. Inverter, this is the inverter. And you see, this is the bubble right here. That means not, okay? A here, and you get not A. That means 0 here, you get 1. 1 here, you get 0. Okay? Not 1 means 0, not 0 means 1. That's a very simple. But inside that IC, you get 1, 2, 3, 4, 5, 6 gates. Okay? And the part number will be 7404. Okay? And now this is a NAND. NAND gate. NAND means not AND. So only thing you can see, this is a simple right here. They get an AND gate, they adding bubble right here. They be not AND.
Hey, Mr. Pham, can you explain that third one, that third, it looks like a,
You see this one, right?
yeah, that one there.
Yeah, we're talking this one first.
Okay.
Okay, now you get the equation. First thing, forget about the bubble. Okay, forget about this bubble right here. So you can get A and B, right? And get, and now you get a bubble here. They put a bar over. Okay, so that's why y equal not A and B. But this equation hard to understand. I want you make sure you understand this thing. I want to break the bar. So y equal what?
Not A or not B.
Now A or not B. That is in the Morgan law. Okay. So this one here telling you, this is a truth table here. If you not want to know, you can see 0, 0, you get 1, 0, 1, you get 1. Okay. However, only one telling me any input equal 0, then output must be 1. Why? The thing is y equal not A or not B. If A equal 0, not A equal 1, and you can argue with anything, they must be 1. 1 or with anything must be 1. Okay, and this is a second symbol. They identical into the NOR, the NAND. However, they using OR gate to build a NAND. Then they adding bubble here. Okay, so same thing. Okay, inside this one, get the 4 gate. 1, 2, 3, 4. Okay, and each input and output. The part number here 7400. Okay, not all get no mean not all. Okay, will be the same thing. That means you see this symbol here. Okay, you understand it or no? Okay, and the NOR part number 7402. So what I want this equation here, y equal not A or B not. I don't want this. I want to break it out. What do you think you get? A turn out to be not A.
And B.
Not B. So this will be telling you one thing. When you see this here, if the input equal one input equal to 1, I know for sure they must be
0.
0. The thing is 1, not 1 will be 0. 0 and anything will be 0. So for the NOR gate, 1 input equal 0 equal to 1. Output must be 0. If you want the output to be a 1, all input must be a 1. Okay?
Well, say that again, Mr. Pham.
I say for
You said if you want the output to be 1.
okay,
Then they all got to be 0.
Yeah. On the output to be a 1. If the input, all of the input must be
0. You circled the wrong one.
No.
He said 1.
Okay. 1 input equal 0. Output must be 1.
I know, but we're doing the NOR gate, and you said that you wanted the output to be 1. You said you want the output.
Okay. If you want the output to be 1, and the 1 input 0, output have to be 1. Right? No.
No. For the output to be 1, all the inputs got to be 0.
Okay.
Oh my God, let him talk.
Let's see.
Okay, go ahead.
1 input equal to 1. Output must be 0. Okay? 1 input equal to 1. Output must be 0. In order for the output to be a 1, all of the input have to be 0. 0. Okay? 0. Okay? Then you get a 1. If you're looking into here, you can see that input 1, input 1, or input 1, input 1, output will be 0. Okay? In order to get the output to be a 1, then A have to be 0, B have to be 0. If you get a C, then C have to be 0. Okay? On the input equal 0, then the output will be 1. Otherwise, output will be 0. You can read that for the NOR gate. Okay? And exclusive OR. Try to get...
Mr. Pham.
Yeah.
I apologize. I think it was a young lady had a question to ask.
Yeah, go ahead. Go
Oh,
ahead.
no, I don't have any question.
Oh, okay. Yeah, anything. Okay. Now, this is just the formula. We follow it. Exclusive OR. Exclusive NOR. Okay, when you see they draw this way, that exclusive OR. When they get a bubble, exclusive NOR. And this is a truth table for you. Okay, you get a 0, 0, you get 0, 0, 1, you get 1. 1, 0, you get 1. That's only telling you, if you get the same input, 1 and 1, output 0. 0 here, 0 here, you get 0. If you get a different input, you get 1. Okay, that's for the exclusive OR. Different input as a logic, you get output to be a 1. If you get the same logic as the input, you get 0. And the exclusive NOR just inverting what on exclusive OR. That's it. What I want you to do, make sure you try to go into the handout. Next time I given you exclusive OR, I given you the input, either 1 or 0, you can tell me right away what is the output. Don't have to look into the truth table. Okay? Then we can do a lot of things. Okay? So that is for today. You get any question, anything else? Okay, anything else?
Thank you.
Okay, we'll see you next week. Next week we don't have a Monday class, okay? Holiday.
Thank you, Mr. Pham.
Yeah, no problem.
Thank you.
Yes.
Thank you,
Try
sir.
to reading your hand now again. Okay. Go to the number 2 and read it.
Okay.
Okay.
Thank you.
Yeah. No Monday on next Monday. Okay.
Okay. Thank you.
Thank you.
Thank you. Bye.
Mr. Smith will be there though Monday.